The next topic is the hydride of the group number 16. The group 16 elements from the dihydride means two hydrogen atoms are attached along with them. So there are few important properties of this hydride. The first one is the bond angle of this hydride. The angle between any two bond or any two adjacent bonds is called as bond angles. The bond angle may be between two lone pairs, maybe between lone pairs and bond pairs, and maybe between two bond pairs. They must be at their adjacent position. So we can see the bond angle of the hydrides of group number 16 decrease from as we move from down the group. So H2 having the highest bond angle, that is 104.5 degree, and H2Te having the lowest bond angle. The polonium is radioactive, so we will not talk about the hydride of the polonium. So as we move down the group, the size of the central atom increases, due to which the bond length increases or electronegativity decreases. So as the size and electronegativity of the central atom decreases, these lone pair are more able to free, or they are more able to shift from one place to another place. So as the electronegativity and size increases, electronegativity decreases and size increases, there is a more repulsions between these lone pair and these bond pairs. So in tellurium dihydride, lone pair bond pair repulsion is highest, due to which this bond angle is the lowest. So the order of bond angle is water, then H2S, H2SC, and the lowest bond angle is for H2Te. Number 2 is the acidic character. Acidic character means tendency to lose the electron. All the hydrides of group number 16 are weak acid and they release their H positive after the dissociation of bond. So the acidic character increases as we move down the group. This is because as we move down the group, the size of the central atom increases, due to which the central atom and hydrogen bond increases, bond length increases, and it becomes easier to release the H positive ion. So the exact order of, or the correct order of the acidic strength is H2O, after that H2SC, then H2SC having the more than H2S, and the acidic character of H2Te is greater than the H2SE. The third one is the thermal stability. Thermal stability means stability towards the heat. And we know that the thermal stability depends upon the bond length. So as the bond length increases, the bond strength decreases. Bond strength decreases, due to which the hydride become less stable to heat. So as we move down the group, the size of the central atom increases, due to which the bond length increases, and as the bond length increases, the bond strength decreases, due to which the thermal stability also decreases as we move down the group. So water is thermally most stable, and H2Te is the thermally least stable among the hydride of group number 16. Next is the reducing strength, tendency to reduce any substance. As we know that the reduction means the addition of H atom. The addition of hydrogen or the addition of H is called as the reduction. And we know that all the hydrides having hydrogen atom, and when these hydride will dissociate, they release the H and can reduce the any species which is reacting along with them. So we know very well the reducing strength is inversely proportional to the thermal stability. As the thermal stability decrease, reducing strength increases. So we know that the thermal stability decreases down the group, so the reducing strength of the hydride of group number 16 will increase as we move down the group. So water is the least reducing strength, and H2Te having the most reducing in nature among the hydrides of group number 16. And the another important is the boiling point. It is important. We know that the boiling point depends upon the molar mass. As the molar mass increases, boiling point will also increases. So as we move down the group, the molar mass increases, so the boiling point should be highest for H2Te and the lowest should be for the water. So the order of boiling point should be H2O, H2S, H2SC, and finally the highest boiling point should be for H2Te. But in case of the water, there is the intramolecular hydrogen bonding. Due to this intramolecular hydrogen bonding, its boiling point will become highest among the hydride of the group number 16. So the actual order of boiling point is H2S having the least boiling point and H2O having the highest boiling point among the hydride of the group number 16 elements. Water is a liquid at room temperature, but H2S is a gas. Why? In case of water, there is the intermolecular hydrogen bonding. Due to the intermolecular hydrogen bonding, the molecules of the waters remain associated with each other. That's why water exists as the liquid at room temperature. In case of H2S, hydrogen sulfide, the hydrogen bonding do not exist, due to which it is exist as a gas at room temperature.